morning, Geo Metro Ninjas, and welcome to another exciting, enthralling, entertaining day in geometry. Today, we get to talk about inductive reasoning that goes along with conjectures and counterexamples. So our first definition is inductive reasoning. Inductive reasoning is simply making a decision based on observations and patterns. So an experiment happens, and then we can make a conclusion based on that experiment. A concluding statement. So when we make a conclusion, so for the last 3 days it's rained, so we expect it to rain again today. That could be a concluding reason. Okay. We call that a conjecture. So it's basically like a hypothesis in science class. For math class, we use a different hypothesis, but for math, a conjecture is a concluding statement reached by using inductive reasoning. So it's an educated guess based on the pattern that we are looking at. So we've seen these before in math class. You guys have done these geometric sequences before. You did a lot of them in Algebra 1. Okay, so it wants us to find the next 5 terms in the sequence and then write a conjecture. Your conjecture is what you think is happening inside of our pattern. So we look at this, we have 38, 31, 24, 17. So we look at the first 2 numbers. We're trying to find a pattern. Yes, sir. What you think? Decreasing by 7. Minus 7. Minus 7. Minus 7. If that's what we believe to be the pattern, our next 5 numbers are going to be 10, 3, -4, -11, and -18. So that's us completing the pattern. And then our conjecture would be just like our classmate said, decreasing by 7. So our numbers are decreasing by 7. Not too bad. About 2, 5, 11, 23. What do you think? 2, 5, 11, 23. Yes, sir.
2 + 1.
Times 2 plus 1. Times 2 plus 1. So 2 times 2 plus 1 is 5. 5 times 2 plus 1 is 11. Okay, does that work? So 4 plus 1, does that make 5? 10 plus 1. 22 plus 1. Okay. So what would our next 5 numbers be? 47, 95, 1, what? 191, 383, 767. Okay. So your conjecture was multiply by 2. Whoops. And add 1. Anybody else see a different conjecture? Nothing stands out. Let's see what I put on the other one. Multiply by 2, add 1. Look at that. Bueno. This is a good one. 1, 4, 9, 16, blank, blank, blank. It is the Uno cards at the top of the board. 1, 4, 9, 16, 25, 36. These are increasing by our perfect square. So 25, 36, that's a highlighter. 25, 36, 49, 64 and 100. 81, sorry. So now you've got a note. Now y'all know why the Uno cards are on top of the board. I did also say it, but a lot of times y'all don't always listen to it. I appreciate that. Sounds like that TikTok. I'm doing my part. I ain't do nothing. Yeah, your conjecture is your hypothesis, your guess about what's happening. How about number 5? 7:30, 7:55, 8:20. Increasing by 25 minutes. So this is the kryptonite of y'all's generation. Y'all don't really look at clocks anymore. You just look at your watch and be like, oh, we're good. All right. So 8:20 to 8:45 to 9:10. Look at my man go. 9:35. 10 o'clock. And 10:25. Nice. Very good. This last one's a tough one. 3-1, 4-1, 5-1, 6-1, 7-1, 8-1. That doesn't seem like a real pattern. What if I said 3.14159? It's the digits of pi. 3.14159 what? 2653 digits of pi. So sometimes they're not always going to be numerical patterns. Sometimes they hit us with a funny shape, or maybe they want us to figure out digits of pi. Did you forget the E? At the end of pi. Is it supposed to have an E? Oh, she added the E. Sir. What job? Do you want to know what job could possibly involve problem solving? Being able to recognize patterns?
Yeah, why do we have to know the distance?
The distance formula. So generally speaking, you probably won't have to know the distance formula in your life. But is there ever a time when you might have to calculate distance?
Oh.
You have to. But what if you're building something? You've got to know length.
I'm ChatGPT.
You could be building a deck for your backyard pool, or redoing the flooring in your house.
Ask ChatGPT.
ChatGPT will help you, but not all the time. You could pay someone to do it, but that's 3 to 4 times the cost when you can just do it by yourself. That's right. All right. Our next thing is a counterexample. So basically, we make a conjecture based on what we see in the pattern. If our conjecture can be proven false, it is proven false using a counterexample. All we need is one counterexample to prove something false. If it's false, you only got to prove it false one time. You don't got to keep going. Okay, so a counterexample is an example that shows that a conjecture, which is simply an educated guess based on patterns, which making a guess based on patterns is inductive reasoning. All we got to do is prove it false with one conjecture. You may have to go through a couple patterns in your brain to see if it works. Okay. You got the first one. Yep. Okay. Yep. Good. So consecutive integers is important here. If you were adding two even numbers, absolutely, you're probably going to find an even. But the fact of the matter is we're talking about two consecutive integers. What is an integer again? Yes. Counting numbers, really. Integers are your counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And they're opposites. What does it mean by opposites? Negatives. Integers are counting numbers and they're opposites. Fun fact, what do you think 0 is? Even or odd?
It's neither. It's odd. It's even.
It's an even number. 0 is considered an even number. It makes sense, right? Because 0, 1, negative 1. Negative 2 is an even number. Okay, this is true. Okay, because like our classmate said, no matter what, if we're adding two consecutive numbers, they're always going to be one even and one odd. So it's always going to end up with an odd number. Okay. The product is multiplication. The product of two numbers is always larger than either number. So basically, when you multiply two numbers together, my number is always going to be bigger. Why no? If we're going to say, we can say no, but you've got to give a counterexample to justify it. Okay, any number by 0 is going to give you a smaller number. Okay, good. What else? What? Negative 3 times 7 is negative 21, which is a smaller example. So this is false. And we provided two counterexamples, but we only need to prove one. Yes, ma'am.
Oh.
4 times 1, because it's not saying it's greater than or equal to, it didn't mean would equal. Yes. Perfect. Okay. The product of two perfect squares is always a perfect square. So this is what we did earlier with our pattern. So 4 times 9, 4 times 16, etc. The product of two perfect squares will always result in a perfect square. Why? Ooh, 4 times 9 is a perfect square.
8 times.
8's not a perfect square.
Oh, sorry.
2's not a perfect square. Okay, what is it? You said 256 times 225. 96? Y'all don't play that goofy game on the internet all the time? 2048? Yeah, not the T-Swizzle. So the square root of 4096 is 64. So let's break it down. This is a true statement. Why do you think it's true? Essentially, you're multiplying by its factors, its roots. So even if I do 2 times 2 times 4 times 4, which we know would be 4 times 16, if we were square rooting it, what's always going to come out? A pair of 2's and a pair of 4's. So when you do this, you're always multiplying by pairs of numbers because a perfect square is just a number times itself. So it's always going to spit out another perfect square. If the area of a rectangle is 6 meters squared, then the dimensions must be 2 by 3. So area, remember that's just length times width. Okay, so this triangle has to be 2 times 3. To get an area of 6, length times width. Well, so we can say no. No's fine. We have to have a counterexample though. Yes. We could do 6 by 1. You can start going into the decimals, right? You can get pretty crazy with it. But the easiest way to get it, you can't have negative length. I like your heads at though. Oh, but length doesn't exist negative in geometry. Now, when you get up into calculus and stuff, you're going to have negative distance, but that's not us. We stay down here in the 2 dimensions. So we know that's false. Yes, that's calc. Okay. Dividing by 2 always results in a number less than the original. Why no? So 1/2 divided by 2 is, you said 1/2 divided by 2, right? What does that create? So we can't divide a fraction by, so we got to keep it, switch it to multiplication and flip it, which makes 1/4. Oh, I mean, it doesn't, that's just one. We can have more than one. All we need is one counterexample to prove something false. Always less than the original number. Anybody else got a counterexample for me? Yes? What if we throw in some negatives? What if you throw in a negative? -8 divided by 2 gives me what? -4. Is -4 less than -8? No. It's greater. So number line, remember, -8 to the right is greater. We're good. Hey, we are bringing back some like 3rd and 4th grade memories right now. It's not always going to be sunshine and rainbows. So we talked about this last unit, vertical angles. What are vertical angles? The ones that go up and down. They're opposite. They're across from each other. Good. Vertical angles are never complementary. What's meant to be complementary? Their sum is 90. Okay. It's all right. We had 5 days off. Don't get mad at yourself. So vertical angles are never complementary. 2 angles across from each other can never add up to 90. False. Yep. If 2 angles are 45. 45 and 45, they would be opposite each other and congruent. This next one is the one that we always get messed up in math. If A times B is 0, then either A is 0 or B is 0. Why false? Why never mind? Oh, A times B. So this is our true statement. Anybody know what the name of this mathematical property? Zero product property. That is 100% true. This is the one where you factor the roots and then you got binomial times binomial equals 0. Then we separate and solve. Zero product property. If 2 angles are supplementary to the same angle, they must be congruent. Supplementary to the same angle, meaning they add up to be 180 with the same angle. True. This is called a supplement theorem. We'll learn this one as we go through this unit. For the people in the back of the room, mic check. Okay. So if I take this example here, okay, if this angle is 135, the one next to it to the left has to be what? 1, more than 1. 45. The angle to the right of it has to be 45. So these are congruent supplements. One of our theorems we're going to learn. Yes, you'll have a whole page of supplements and theorems that you're going to love. All state names have at least 2 syllables.
No.
What do you mean no? Listen.
Yeah,
Georgia has 2.
Maine. And Florida. Alaska.
Alaska has at least 2. Maine?
Iowa.
Ohio's got 2, yeah. It's Maine. The answer is Maine. It says, yeah, it's just Maine. All right, and then number 16, we've already seen this before. Squaring a number and adding 1 will always result in an even number. Squaring a number and adding 1 will always result in an even number. If we're going to say false, we got to provide why. Okay. 2 squared is 4. 4 plus 1 is 5. Is that an even number? Nope. Perfect. We figured it out. I think that's the end of it, right? That's all we're doing today? Perfect. All right, so that concludes our lesson for the day. Absolutely. And remember, go be great.